Number 4 is interesting. We're given secant of sine inverse of a over b, and so this ratio has no numbers. But that's okay, we can still build a reference triangle using the ratio, using a and b for side lengths. One issue, however, that comes up, because we don't know exactly what the values of a and b are, there could be a difference if a and b is a positive ratio versus if a over b gives us a negative ratio. So let's assume that it's positive, so that ratio would belong in quadrant 1. We would have a sine ratio that's positive, so it would belong in quadrant 1. And even though I don't know what a and b are, I can place a along the opposite side and b along the hypotenuse. And then using the Pythagorean theorem, I know that the unknown side has to be the square root of b squared minus a squared. So the secant ratio is going to be the hypotenuse over the adjacent side. And so we know that secant of sine inverse of a over b is going to be b over the square root of b squared minus a squared. So a couple things to think about. I know that, like in this diagram, the value for b should be positive. I don't necessarily know that the number that b represents is positive, but as a side length of the hypotenuse, it should be a positive value. And what comes out of this square root is obviously going to be positive. The x-coordinate is positive here in quadrant 1. So I know that I want my answer here to be positive. So I should probably add a little something. I could put absolute values around that b. I might add just here the words, I want to assume that b is greater than 0. Because there is a little bit of a sign issue. We don't quite know whether a and b represent positive or negative values. If the ratio overall is negative, we would end up with a picture in quadrant 4. So our picture would look slightly different, but it would essentially be the same. I would have a hypotenuse of b, I would have a vertical opposite side of a, and then this would still be the square root of b squared minus a squared. And so now in this diagram, a is less than 0, but when I square it, it's going to become positive, and so this amount would be exactly the same, and so our answer would be exactly the same, of course assuming that the actual number that b represents is positive, because I want my final answer to be positive.